So in this problem, we're given the area of a square, and we want to know how long the diagonals are. So there's a couple ways we could approach this. Number one is, of course, draw ourselves a square with 90-degree angles and all equal sides. And we want to know how long these are right here. What's the diagonal? Okay, so we know that the area is 1800 and the formula is side squared. So when we take the square root of both sides, we get the square root of 1800 as the length of one of these sides. Root 1800, which I'm sure can be simplified. But now we can use our buddy Pythagoras. Are you familiar with Pythagoras? He says that the sum of the squares of the legs of a right triangle, so because it's a square, the legs are the same, is equal to the square of the hypotenuse. In this case, the hypotenuse is the diagonal of that square. Now, squaring radicals is pretty easy. They just cancel each other out. So I have 1800 plus 1800 equals diagonal squared, which I believe adds up to 3600. And when I take the square root of both of them sides, I believe I get 60. Now, that's a nice diagonal right there. 60 inches long. It's pretty good. It's 5 feet. But there's another way that we can think about this. What if I were to turn my square on its corner like this? Then we might think about this as a different kind of shape known as a rhombus. Now, in a square, the diagonals are equal. So I can say 1800 equals half of my diagonals times my diagonals, since they're both the same. Now, multiplying both sides by 2, I get a very similar thing to what I just did over there with Pythagoras, only with a lot less steps. But I still get the same diagonal.